We start with the inequality absolute value of x less than or equal to 4. Now this wasn't on your document, this is just a discussion. If the absolute value of x is less than or equal to 4, then can you give me, and don't look down, think about it, can you give me the set of integers that satisfy this relationship? Okay, now you should pause and do that, but I'm going to say now, well, it's clearly true if x is equal to 0, 1, 2, 3, because the absolute value of any of those numbers is equal to the number, and it's certainly less than or equal to 4. It's also true when x equals 4. We do have to be careful about that, make sure we have a less than or equal to and not a less than. We wouldn't be able to include 4 if this was a less than. Okay, now it's also true though for other values. Can you think of what those values might be? At least one of them. Well, it would be true for x equals negative 4. Okay, because the absolute value of negative 4 is 4, and 4 is less than or equal to 4. It's also true for negative 3, negative 2, negative 1, because the absolute values of those numbers are, respectively, 3, 2, and 1, all of which are less than or equal to 4. It follows then that the absolute value of x is less than or equal to 4 for integers if x is anything from negative 4 to positive 4. Now clearly, for any numbers in between the integers, starting at negative 4, ending at positive 4, then it's going to also be true. Now, I'm going to state this, though, in this way. I'm going to say, so, absolute value of x is less than or equal to 4 if x is less than or equal to 4, which is certainly true for any of these numbers. But we need more than that, because there are numbers less than or equal to 4 that don't make this true. For example, negative 50. If x is negative 50 is less than or equal to 4, but negative 50 does not satisfy this. X equals negative 50 does not satisfy this. We have to have another condition as well, that x has to be greater than or equal to negative 4. That squeezes x between negative 4 and 4. X less than or equal to negative 4 could look like this green arrow. Okay, if this is negative 4 here, everything to the left would be all the values of x that are less than or equal to negative 4. And are less than or equal to 4, I'm sorry. So if this is 4, this represents all the numbers that are less than or equal to 4. And this arrow represents all the numbers that are greater than or equal to negative 4. The only numbers that satisfy this condition would be the numbers between here and here, corresponding to this red interval. Okay, now I've got an and written there, and we'll talk about the and the or separately. I'll just say right now that clearly x has to be less than or equal to 4, otherwise it's not so. X has to be greater than or equal to negative 4, otherwise it's not so. And x has to be both of those, and that's what we mean by the logical and. If we say something and something, it means they both have to be true. So we both have to be on this arrow, in the region described by this arrow, and the part of the x-axis described by this arrow, and that gives us this region here. More about this shortly. This set of inequalities can therefore be written negative 4 less than or equal to x less than or equal to 4. Negative 4 is less than or equal to x, which is the same as this inequality, and x is less than or equal to 4, which is the same as this inequality. Now, absolute value of x greater than 4. Let's consider this equation, okay, or inequality. Okay, can you tell me what integers this is true for? Well, you should pause a little bit and think about it, but assuming you've done so. It's certainly true if x equals 5, and it's not true for, well, okay, it's true for x equals 5, and it's true for x equals 6 and x equals 7, and it's clearly true for any of the integers beyond that. So there's an infinite set of integers for which this is true. It'd be 5, 6, 7, and so forth. Okay? Now what else could it be true for? Well, x equals negative 5, negative 6, negative 7, and so forth. The absolute values are still going to be 5, 6, and 7, and they're all greater than 4. And it's clear that all the numbers that follow in this pattern, all the negative numbers all the negative integers starting at negative 5 will satisfy this inequality. So we can say that it's true for, well, okay, let's just go to the numbers for which it's true. If we don't restrict ourselves to integers, it's clear that any positive number that's bigger than 4 is going to satisfy this inequality. So we can say the absolute value of x is greater than 4 if x is greater than 4. Now there's an or here, but we don't need to think about that just yet. That's all we need to make a true statement. Now we haven't given you all, this doesn't include all possible values of x that satisfy the inequality, but if x is bigger than 4, then absolute value of x is bigger than 4. Now notice the difference between the situation here and the situation here. X less than or equal to 4 is not enough all by itself. We need x greater than or equal to negative 4 as well. And this isn't sufficient by itself. We need this, so we need both of these. Here, it's true, provided x is greater than 4 and we don't have to even answer any other questions, we have a true statement. So this is greater than 4 if x is greater than 4, end of that part of the story. But of course, there are negative numbers for which it's true, and you can verify that those are the numbers for which x is less than negative 4. Okay, if x is less than negative 4, this inequality is again true, just as it is for negative 5, negative 6, negative 7. But any number less than negative 4 is going to satisfy. So, this condition alone makes the statement true. So, this condition can be true, or this condition can be true. Either way, it makes the statement true. In contrast to up here, where it has to be, we have to satisfy both conditions in order to make the inequality true. So, this statement in green isn't relevant to this part of the discussion. So I'm going to stop there. I'm just going to say then that we conclude that the absolute value of x is less than or equal to 4 if negative 4 is less than or equal to x and x is less than or equal to 4, which is what this says. Absolute value of x is greater than 4 if x is greater than 4. End of that part of the story. Also true if x is less than negative 4. There's no and here. The test is got to be this or it's got to be this. And it can't be both in this case, because if it's greater than 4, it's not less than negative 4. If it's less than negative 4, it's not greater than 4.